Okay, I'm gonna do my first request video. Someone asked us to do a video on synthetic division, so we're gonna do that today. First of all, what is synthetic division? Well, you may have seen that in your algebra class or whatever maths classes you're taking, that sometimes you want to divide two polynomials. And what you can do is you can use long division. But synthetic division is another algorithm that can be used as an alternative in some situations, and that's what I'm going to tell you about next. Okay, so when can we use synthetic division? Okay, so we've got a polynomial, say some polynomial like b by something like that. Now, you can't use synthetic division if we have a coefficient in front of the x here. We can only use it if we're dividing by a function of this form here, where this c here is obviously a constant and that d is a constant d. Right, so the easiest way to understand synthetic division is to do examples. So let's look at some examples now. Right, so I want to divide this by that using synthetic division. What I do is, it's an algorithm that you just have to remember. You take the negative c here, so multiply this minus 2 by minus 1, which is 2, and put that there. Then we'll read off these coefficients. We'll put these right here, starting with the highest power here and working our way along. Right. Now, what we'll do is we'll times this 2 by 0, which is 0. Then we'll take that away, that's 3. And after that, we'll multiply these two numbers here, this 2 by 3 here, which is 6. And we'll take that away from minus 4, and that'll give us minus 10. And then we'll do the same again with this one here now. Multiply this, so that's minus 20. Subtract that, I get minus 21. Now, this number at the end here is the remainder. Oh, and this one here is a constant. That one there's with first power. So we'll get 3x minus 10 with remainder minus 21. Or if you like, we can rewrite that as because that's what a remainder means. Okay, so we've got some more examples to do now. Rub things off so we've got more room. Yeah. So one look at example 2 here. This is a much harder one. So write this. Remember, we'll take the negative one. So it's going to be minus 4. Then we'll take these numbers here, the coefficients. 2, 3, minus 17, minus 27, and minus 9. Oh, but I don't run out of time here because this is a long problem, it's hard. Right. That's 0 obviously because we're timesing it by. No, it's not, it's a 2, that there is 0. Then we're taking that away, so that's a 2. and we'll multiply as we did before, so that the minus 8 one, multiply it, and then here I get minus 5, multiply that, and get 20, add 20, take away 20 from there, get minus 37, because I'm taking that away. So next, I want to times 4 by minus 37. That's a hard calculation, so what I'm going to do is I'm going to work this out. So 7 is 28, 30, 120, 48. So that's 148 there, I think. This is a very hard problem here. Really, you should not do it this way, but I have no choice here. So, as you can see, the numbers are getting a bit too complicated on that one, and I'll be wasting a lot of time if I do it, so we're going to skip example 2. Could easily work it out and give you a solution, but I'm not going to have time, and with the time limits here on YouTube, so we're going to have to skip it. Right, let's look at example 3 then. Sorry about that. That's a 3. Now the x squared, we don't forget about it, we'll put 0. We'll put minus 4, minus 1. And then again, this is a 0. And then, after that, what we'll get is, we get 3, and we'll multiply 6, take 6 away from 0, get minus 6, and then 1 times that. 2 times minus 6 is minus 12. Because we're taking away a minus, we'll add it, so we'll get 8 there. And we'll times 2 by 8, that's obviously going to be 16. I'm taking that away from 1, so we'll get minus 17 here. And remember, of course, that's the remainder. So, we've got, let's see, 3x squared minus 6x plus 8 plus minus 17 minus 2. And an application of this is you could use it to factorize a polynomial completely, something of the form could factorize that completely, and then you could solve it equal to 0 and get your 3 solutions here, like something like which of course you would recognize that x could equal minus 3, x could equal 2, x could equal minus 4. There's also other solutions, but we'll talk about that later, and I'm running out of time now, so we'll have to stop it there. And if you've got any questions, you can obviously put them on the video and I'll answer them, and I can also give you the solution to that problem I didn't have time to work out, if you like.